right where we left off. So we just discovered the relationship between circumference and diameter is that 3.14 number. So we now know that this formula to find and calculate circumference is circumference equals pi times diameter. Now this is something that you did learn last year, so that's why I kind of moved through it quickly. We're going to do a couple more practice problems and then move straight through to some new stuff. So if I tell you that the diameter of this circle I have right here is 5.5 meters and I want to know what the circumference is, how are we going to do that? And now I don't need you to use a calculator. We're just going to do this in terms of pi. So we aren't going to actually use 3.14 at all. We're just going to treat pi as its own entity and keep it as is. It's actually the most precise way of calculating it. So in order to find circumference here, the answer is just 5.5 pi. That's the most simplified form. By multiplying it by 3.14 instead of that super long number, you're just rounding. So it's better to just write it in terms of pi. So that was good. We're going to do a very similar question, but this time instead of me giving you the diameter, I'm going to start by giving you the circumference, and it's going to be in terms of pi. So if I tell you the circumference is 17 pi, what is the diameter? So the diameter is just 17. It's the number being multiplied by pi. Now you'll notice in the equation, it says pi times diameter, and then here I have diameter times pi. The order doesn't really matter, but we do typically put whole numbers in front of pi for our final answer. The formula just has it after pi for whatever reason. Okay. So now another similar question. What if I tell you that the radius, so just that part of the circle, is 6 centimeters? Then what is the circumference in terms of pi? So then now the answer is going to be a little different because the first thing you have to do is first find the diameter. And the diameter is going to be 12 because the radius is only half of the diameter. And then to find out, now we have our diameter, we can say that their circumference is 12 pi. If you're wondering how I draw my pi, I just draw a simple 11 and then that little squiggle on top. That's the simplest way to draw it. All right, one more simple review one and then we'll move into the next part of today. What if I tell you that the circumference is 30 pi and I want you to tell me what the radius is, so not the diameter? What do you think the answer to that question is? What is the radius if the circumference is 30 pi? All right, so if the circumference is 30 pi, then we know that the diameter is 30. And then therefore we can say that the radius is half of the diameter, so the radius is 15. Very good. I lied, I'm actually going to do one more. What if I say the circumference is just 30 and there's no pi there? So this is where it gets a little bit different. It's not as visual, it doesn't look exactly like the formula. So in this situation, you'd plug in 30 in for C. And then we would try to isolate D all by itself. So in order to get D all by itself, it's now being multiplied by pi. What could I do to get D isolated on the right side of the equation? I can divide by pi on both sides. So in this situation, pi cancels out, and the answer in terms of pi is 30 over pi. You can do that on a calculator, but for our purposes, I wanted to keep our answers in terms of pi, so it would just be 30 over pi as our final answer. Okay, we're going to be using that for the next part of what we're going into, so let's move on to that part. So what we have here as our next part is a term we already know, which is arc measure, and a term we haven't quite defined just yet, which is arc length. And they are two different things, though they're very easy to get confused, so this is why it's important that we're taking notes and we know the difference. An arc measure is the amount of space of the circle that an arc takes up. So in this situation, the purple, the red, and the green arc all have the same arc measure. Arc measures are measured in degrees, so each of these has an arc measure of 90 degrees. However, they do not all have the same arc length. Arc length actually talks about, it's kind of like the portion of the circumference that it covers. So which of these has the greatest arc length, purple, red, or green? Right, the biggest circle is going to have the biggest arc length. So even though they all have the same arc measure, which is measured in degrees, they don't all have the same arc length, which is measured in things like centimeters and feet and inches and those standard units of measure. And we're going to learn about how to actually calculate arc lengths today. That's what we're going to focus on. So looking here, you see that these are each 90 degrees, which that is their arc measure, but we don't quite know how to find their arc length yet. So let's dive into that. So, first question I have to ask you in order to be able to answer these questions is, to start, how many degrees are in a circle? Circles, open layer's wrong, screen. Circles have 360 degrees. If you don't have that written down and you didn't know that off the top of your head, that should most certainly be going in some type of circle notes. This, like I said, is the last new piece of information, so we will be moving towards an assessment sometime next week. So make sure you have those notes nice and organized so you can use them to help you on whatever assessment I give. So yes, a circle is 360 degrees all the way around the circle. So that's going to be helpful in talking about arc measure and then therefore arc length. So let's look at each of these images. We have 3 arcs here. I highlighted them in pink to be specific. So this arc right here on the left is arc AB. The second one in the middle is arc CED. It's a semicircle. And then we also have this arc EF. And I kind of drew over it, but it says arc EF is 120 degrees. And I'll just make that a little bolder so we can see. So I want you to go ahead and answer, what fraction of the circle T is arc AB? So knowing that it's a right angle there, we have 360 degrees in a circle. What fraction, reduced to simplest term, is arc AB? All right, so let's talk about this. If we have a right triangle that's a 90-degree angle, divided by over our full amount of degrees in a circle, which is 360. If you do 90 divided by 360, you'll get 0.25, but I wanted a fraction, not a decimal, so it's actually 1/4. You can divide 90 by 90 and 360 by 90 to reduce it to 1/4. So this arc AB is 1/4 of the circle. Now let's talk about arc CED. What fraction of the circle is arc CED? So this is a semicircle, so we have 180 degrees in the semicircle, and it's divided by the 360 degrees, which is just 1/2 of the circle. Okay, and lastly, we have this arc EF, which it has an arc measure of 120 degrees. What fraction of circle P does arc EF take up? All right, so we would do 120 divided by 360, and that gives us 1/3 of the circle. That's going to be the first step in finding arc length, is to first determine what fraction of the circle the arc measure takes up. So this takes, on the first question, this was 1/4 of the circle. This middle question, it was 1/2 of the circle, and over here was 1/3 of the circle. Okay? So now let's do this with a radius. So let's say our radius is 5 on this figure right over here. If we have a radius of 5, what is the diameter? The diameter is going to be double that, so it's going to be 10. What is the full circumference of this circle? So the full circumference is the diameter of 10 times pi. We're not even going to multiply it by anything, just in terms of pi. But now here's the tricky part. We aren't asking, the next part is, what is the measure of just that pink arc? So if we know the full circle is 10 pi, and I want to figure out what just that pink part is, well, the pink part is just 1/4 of the circle. So it's going to just be 1/4 of the circumference. So if we know that the circumference is 10 pi, I can say that arc AB equals 1/4 times 10 pi. Now the last step to there is to just make that one number, so 1/4 times 10 is just 10/4 pi, and that would be my answer. Okay? So now let's try it with question B. I'll say that the diameter, I'm going to give you the full diameter, is 12. So if the diameter equals 12, what is the circumference? The circumference is going to be 12 pi. And now I want to figure out what is the arc length of CED. Well, if we know the full circle is 12 pi, and arc CED is a semicircle, so it takes up half of that circumference, we are just going to multiply it by the fraction of the circle it takes up by the total circumference. And then our last step here is to just do 1/2 times 12, and 1/2 times 12 is what? It is 6. So the answer for the measure of that arc length is 6 pi. All right, one very similar to it, but now we're dealing with this 120-degree arc. So arc measure is 120 degrees. We decided that means it takes up 1/3 of the circle. And let's say the diameter, I'll just put it right there. We're going to say that the diameter is 9. Okay? So if the diameter is 9, what is the circumference? Good, the circumference is going to be 9 pi. And then what is the measurement of arc EF? How am I going to calculate arc EF? I'm going to multiply the fraction the arc takes up, which is 1/3, times the total circumference, which is 9 pi. So now I'm doing 1/3 times 9 pi, and 1/3 times 9 is just 3. So the answer to this full arc length is 3 pi. Now, I'm going to just pause and remind you that especially if you're watching this during your class session, if you have any questions, please reach out to me on GoGuardian or send me an email. If you want to do Google Meet, you can always do so. It is important that you're really checking for understanding and making sure you're asking questions the same way you would if we were in class in person. All right, so now let's move on to a couple more review problems. Here I have a circle that has an arc measure of 135 and a radius of 8 centimeters. I'm going to first give you a chance to try to solve this on your own, just with that given information, and then I'll walk you through the steps. If you're not sure exactly what the answer is, but you think you know a couple of the steps along the way, just type out your thought process of what you should do, even if you're not certain of the actual answer. All right, so what we're first going to have to figure out is what fraction of the circle does this arc take up? So we know that the arc is 135 degrees, and we know that a circle has 360 degrees. So first we're going to make a fraction of that part to whole ratio, 135 divided by 360. Now I have not done this problem myself yet, so I don't actually know what the fraction is off the top of my head, so I'm doing the problem right along with you. 135 divided by 360. That's not one that we just know off the top of our heads, like 180 divided by 360 or 90 divided by 360. So we're going to have to look to reduce it in the best way we can. What I see right away is that 135 ends in a 5, 360 ends in a 0, so I know they're both divisible by 5. So I'm going to take 135 divided by 5, and I get 27. And then I'm going to take 360 divided by 5, and I'm going to get 72. And then I realize that that's actually not the fully simplified answer, because I know 27 and 72 are both divisible by 9. So 27 divided by 9 is 3, and 72 divided by 9 is 8. So this 135 degrees is 3/8 of a circle. Okay? Now that I know it's a 3/8 of a circle, I can start doing the rest of solving for how long that arc is. So now I have to figure out what is my diameter. So it's giving me a radius of 8 centimeters. My radius is 8 centimeters. What is my diameter? So my diameter, if my radius is 8 centimeters, my diameter is 16 centimeters. Okay? If my diameter is 16 centimeters, what is my circumference in terms of pi? Okay? So my circumference is 16 pi. 16 times pi, that's the formula we reviewed in that previous video. All right? But that's not the last step, because we're not looking for the circumference. We're just looking for the arc length of that purple arc we have highlighted here. All right? So let's get calculating. We know that that purple arc takes up 3/8 of the circle. And we know the total circumference is 16 pi. So we're going to I'm going to name this arc MC. So I'm going to say arc MC equals 3/8 times the circumference of 16 pi. Now 3/8 is not a number I multiply by very often, but let's remind ourselves of how to multiply fractions. If I'm doing 3/8 times 16, that's like doing 3/8 times 16 over 1, and we can cross reduce. 8 becomes 1, 16 becomes 2, and then it's just a simple math problem of multiplying across. 3 times 2 is 6, 1 times 1 is 1. So arc MC equals 6 pi centimeters. If you got that, that's so awesome. If you didn't get it, that's totally fine. It's going to take a little bit of practice.